So in this lesson, we're going to talk about how to use the quadratic formula. Hopefully you've seen one or two of my videos on how to derive this formula, but you can do it by either using completing the square or by using vertex form and standard form. But either way, we get our solutions to this ax squared plus bx plus c equals 0, the standard form of a quadratic equation. Our x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And notice how it says real solutions. That means that we can't have the square root of a negative number here. So this whole thing, b squared minus 4ac, has to be 0 or larger. And then a obviously can't be 0 because we can't divide this by 0. But anyway, we'll talk about this, b squared minus 4ac, in a little bit. This is called the discriminant. But let's get into our first example. All right, so we have 2x squared minus 5x plus 3 equals 0. And we're supposed to solve it using the quadratic formula. Well, let's write down our formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So now I'm just going to identify a, b, and c in this quadratic equation. So remember, a is the coefficient of the x squared term. B, which in this case will be negative 5, is the coefficient of the x term, and then c is the constant. So I know that a equals 2, b equals negative 5, and then c equals 3, positive 3. So now I just have to plug all of these three values into this quadratic formula in order to solve for my two x values. So I get x equals negative, and then I'm plugging in a negative number. Anytime you plug in any number, it's a good idea, but especially a negative number, put parentheses around it. So negative, and then negative 5, and then plus or minus the square root of negative 5 squared minus 4 times a, which is 2, times c, which is 3, and then this is all over 2 times a, which is 2. All right, now this will be probably easier if you use a calculator, but you don't necessarily need one. So we can just simplify this. We get x equals positive 5 plus or minus the square root of, well, this is negative 5 squared, the quantity, is 25. And then negative 4 times 2 is negative 8, times 3 is negative 24. So this is 25 minus 24 all over 4. All right, so now this is going to give me the square root of 1. I'll just rewrite that really quickly. X equals 5 plus or minus the square root of 1 over 4. But the square root of 1 is just 1. So that's the same thing as 5 plus or minus 1 over 4. All right, so now what we can do is we can separate this into our two values. So one of my x values is going to be x equals 5 plus 1 all over 4. The other one is going to be 5 minus 1 over 4. So in this case, 5 plus 1 is 6, so I get 6/4, which is 3 over 2. So this is one of my x values. And then here I get 4 over 4, which is just 1. So x equals 1 here. So my x values are x equals 1 and 3/2. These are the two values that if I plug into our original equation, which is all the way back up here, will make that equation true. Another way to say this is these are the two zeros of the parabola that would correspond to this quadratic equation. So yeah, now that we've solved these two x values, we are done. All right, so for this example, we have the number y of northern Rocky Mountain wolf breeding pairs x years since 1990 can be modeled by the function y equals 0.20 x squared plus 1.8x minus 3. When were there about 35 breeding pairs? So if we look, y is the amount of breeding pairs. okay, northern Rocky Mountain wolf breeding pairs. And X is the number of years. So we're solving for X here, okay? So our equation is actually going to look like this. 35, because that's how many breeding pairs we want for Y, equals 0.2 x squared, we don't know what x is yet, plus 1.8 x minus 3. Well, we want to use the quadratic formula to solve this. And the way I want to do this is first I need to put this in standard form. So basically I need one of the sides to be equal to 0. So I'm going to subtract 35 on both sides, and I'm going to get 0 equals 0.2 x squared plus 1.8 x minus 38 in this case. So now this is my standard form quadratic equation. So now what I want to do is I want to identify my a, b, and c values, because those are what I'm going to plug in. So a is the coefficient of the x squared term, so that's 0.2. b is the coefficient of the x term, which is 1.8. And c is the constant, which is negative 38. So now I'm going to rewrite my quadratic formula in the general form. I suggest writing it in the general form before every equation, or before every problem that you use, because it'll help you remember it. So we have x equals negative b plus or minus the square root b squared minus 4ac all over 2a. So now I'm just going to plug in my values. Well, b is 1.8, so I'm going to write down negative 1.8 plus or minus the square root of 1.8 squared minus 4ac, so that's going to be minus 4 times 0.2 times c, which is negative 38. And then all over 2 times, well, a, if you look at it over here, is 0.2. So all over 2 times 0.2. Now, once again, you could do this out. But since we did the last example out, let's use a calculator for this. So I have Desmos up right here, the scientific calculator. And I'm going to type in negative 1.8. And I'll do plus first, and then I'll easily be able to change it to the minus. So plus, and then the square root of quantity 1.8 squared minus 4 times 0.2 times negative 38. And then this is all over, so I'll just highlight this all, hit divided by, and then 2 times 0.2. All right, so all this mess, we get a clean answer of 10. So one of our x values, I'll write down here, is x equals 10. Once again, you could have solved this by hand, but it's probably quicker to use a calculator in this case. And then all I have to do to find the other solution is just change this plus to a minus. That's what the plus or minus means. You have both of them as your solution. And now I have x equals negative 19. Well, let's discuss this in the context of the problem. If I go back up here, we see that x is the amount of years since 1990. Well, on this graph, we don't have any year before 1990, and this negative number, negative 19 in this case, would suggest that the breeding pairs would go back in time, which that's not the case here. So we can actually reject this negative solution. So the only solution here is x equals 10 years. So 10 years after 1990 is going to be the year 2000. And here, that doesn't really matter. So we want 10 years. So if I look at my graph to see if this all makes sense, I'll go to about 10, which is probably right around here. And I'll go up, maybe like right there. So this point right around here makes sense, because you could argue that this is about 35 breeding pairs and that this is about 10 years. So that's another way to check. Here we were given a graph, so it's a good way to see whether or not our answer makes sense. In this case, yes, it does. It does match with the graph. So our answer is going to be 10 years since 1990, or the year 2000. And now we're done. All right, so like I mentioned earlier, we're going to talk about this discriminant, which is b squared minus 4ac. And the reason this discriminant is so important is because the square root is going to tell us about how many solutions we have. If this discriminant is positive, we're going to have two solutions because we have both plus or minus the square root. Each positive number has two square roots, a positive one and a negative one. If this discriminant is 0, we're going to have one solution because plus 0 and minus 0 are the same thing. So that's going to be a redundant solution. So it's really only going to be one unique solution. Now, if this b squared minus 4ac is negative, we know that we don't have any real numbers that we can square to get a negative number. So this is what's going to give us complex solutions, and you'll learn about those in Algebra 2. But for now, we just want to know how many real solutions we have. So once again, when b squared minus 4ac is greater than 0, we're going to have two real solutions. When b squared minus 4ac is equal to 0, we'll have one real solution. And then when b squared minus 4ac is less than 0, we're going to have no real solutions. Now, down here, we have graphs of parabolas that show what that means if we were to graph the corresponding quadratic function to that quadratic equation. So in this case, if the discriminant is positive, that means that the graph will go through the x-axis twice. If the discriminant is 0, that means that the graph will just touch the x-axis at one single point. It won't go below it. It'll just touch it. And then if this discriminant is negative, that means that our parabola will not intersect with the x-axis at all. So it's basically saying when does this parabola equal 0? It doesn't with any of our real numbers. So that is how to interpret the discriminant. All right, so this question says, determine the number of real solutions of x squared plus 8x minus 3. Well, the easiest way to do that is to just figure out what the discriminant is and then analyze from there. So if we remember, the discriminant is just the part of the quadratic formula that's under the radical, which is b squared minus 4ac. In this case, a is 1, b is 8, and c is negative 3. So this is a equals, b equals, and c equals. So I'll just plug these values in, and then I'll analyze it from there. So I get 8 squared minus 4 times 1 times negative 3. So this gives me 64, and then two negatives make a positive, and then I get 12. So 64 plus 12, which is equal to 76. So my discriminant is 76. If we remember, a positive discriminant means that this is going to be the number under the radical. Every positive number has two real square roots. So that means that we're going to have two real solutions. So determine the number of real solutions. Since our discriminant is positive, we have two real solutions. All right, so for this one, we're going to do the same thing, determine the number of real solutions, but this time we're given an equation that is not in standard form. So we need to solve this for standard form. Remember, standard form is when we can write it as ax squared plus bx plus c is equal to 0. So I'm going to try to set this side equal to 0, and I'm going to subtract 6x on both sides, and then rewrite this in standard form, which is 9x squared minus 6x plus 1 equals 0. Now what I want to do is find my discriminant, b squared minus 4ac, and then I will analyze. So my a value is 9, my b value is negative 6, and my c value is positive 1. So I'll rewrite this as negative 6 squared minus 4 times 9, that's our a value, times 1. Okay? Well, negative 6, the quantity squared, is 36. And then minus 4 times 9 is negative 36 times 1, still negative 36, we see that this is going to cancel out and become 0. If you remember, when our discriminant is 0, that means we're taking the square root, both plus or minus the square root of 0, but plus 0 and minus 0 are the same exact thing. So in this case, since our discriminant is equal to 0, we're only going to have one unique solution. One real solution. So for this example, it wants us to find the number of x-intercepts of a parabola for the function y equals 2x squared plus 3x plus 9. Well, if you remember, this corresponds to the quadratic equation of 0 equals 2x squared plus 3x plus 9, because the x-intercept is the value of x when y equals 0. So if I just set y equal to 0, I get this quadratic equation. And if you remember, to determine the number of zeros, or the number of real solutions in this case, we just have to use the discriminant. So that is b squared minus 4ac. So I will identify my values. This is a, then positive 3 is b, and then positive 9 is c. So I'll plug those in. So I get 3 squared minus 4 times a, which is 2, times 9. And then when I simplify this, I get 9 minus 4 times 2 is 8. 8 times 9 is 72. So minus 72, which is going to give me negative 63. So since my discriminant is a negative number, that means that there's no real number that I can square to get to a negative number. So that means that there's going to be no real solutions to this quadratic equation, which means that this quadratic function is never going to touch the x-axis at all, which means that there are 0 x-intercepts. And that's our final answer. All right, this last example is letting us pick which method we want. We've done all sorts of methods. We've done by graphing, we've done by the quadratic equation, we've done by completing the square, and we've done by factoring. So it's going to have us choose whatever method we want and then explain why. Well, I'm actually going to explain first and then solve it that way. So this way, I mean, once again, you can solve them all by completing the square, using the quadratic equation, and then get a good estimate of everything by graphing. But in this case, I am going to choose to complete the square because I already have an x squared with no coefficient and then my x term. So all I have to do is just divide this b term by 2 and then square it. So negative 10 divided by 2 is negative 5. And then negative 5 quantity squared is 25. So all I have to do is add 25 on both sides. I get x squared minus 10x plus 15 equals 26. And then when I factor this, I don't know why I put 15 there. This should be 25. And then when I factor this, this becomes x minus 5 squared equals 26. And now I can take the positive and negative square root of both sides. And up here to the right, I get x minus 5 equals plus or minus 26. Then I'll add 5 on both sides. And I get x equals 5. Oh, this needs to be square rooted, sorry. X equals 5 plus or minus the square root of 26. And these are my two solutions. So, in my opinion, that was a pretty quick way to do it by completing the square. Now for part B, I am looking at this and I see that I have multiple coefficients. I could try to factor it. I could try to simplify this down to complete the square. But I am just going to use the quadratic formula because to me that seems quick and I know it certainly will work. So I'm going to rewrite the quadratic formula. X equals negative b plus or minus square root of b squared minus 4ac all over 2a. Now I'm going to plug my values in. A is 2, b is negative 13, c is negative 24. So I'm going to get x equals positive 13 plus or minus square root of 13 squared minus 4 times 2 times negative 24 all over this whole entire thing. And I don't even need this positive sign now that I'm looking at it. All over 2 times 2. So I could do this out, but I am just going to use my calculator. So, and I actually have this last example up, so I'm just going to replace some things. So positive 13. I'll do minus first because that's what's there. And then 13 squared. And then minus 4 times 2 times negative 24. All over 2 times 2. Nope, just want this. All right, so one of my values is negative 1.5. And then if I change this minus to a plus, I get 8. So my two answers are, once again, 8 and negative 1.5. So I go back over here. I'll write down x equals negative 1.5 and 8. These are my two x values that solve this equation. So that was using the quadratic equation method. Once again, you can use any method to try to solve these equations, but I chose quadratic here because we had coefficients. I didn't think it was going to be too easy to factor or complete the square. So that's how to do part B by the quadratic equation. Part C, I have x squared plus 8x plus 12. So right now I'm looking at this and I think that it might be able to be factored, and factoring is a pretty quick way to solve it if it can be factored. So I'm going to look at my two values here, b and c, and you would usually look at a as well, but a is 1, so I don't need to worry about that. So I just need to find two numbers that add to 8 and multiply to 12, and I know that that's 6 and 2. So I can just rewrite this as x plus 6 and x plus 2 equals 0. And I know that from the zero product property, if I just get these two things in the parentheses equal 0, the whole equation will equal 0, which will make this true. So if I plug in negative 6 and negative 2 for my x values, those will make this equation true. So I'm going to get x equals negative 6 and negative 2. And these are my solutions, and I chose factoring because I felt like it'd be the quickest way. But now we're done.